All right, CanFigureIt. Here we go. Let me share my screen. All right. I know some of you have other classes and stuff to go do. Sorry, I'm taking up your whole day. Okay, so let's do, does anybody have a request for what type of proof we do now? Either throw it in the chat or unmute yourself if you have a request. Anybody? You just want me to pick one? Triangles, got you. Okay. Triangles it is. So let's look. Oops. Let's look at which ones we've already. Wait, what's happening? Okay. All right, so let's do something similar. I just want to show you guys how easy some of these are because they're a little deceiving. Okay. So we have that we want to prove that these two triangles, and again, if you hover over the unjustified claim, it'll kind of highlight what it's claiming on your picture. So GHM, the purple triangle on the left, we're trying to justify that it is congruent to RPM, the purple triangle on the right, okay? And all of these triangle congruence things are using our shortcuts that you did in the purple packet. So there was like angle, angle, side, angle, side, 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 that kind of thing, okay? So let's just look at this picture for a second. It gives us information over here in the justified claims. Tells us that M, that dot in the middle, is the midpoint of GR. Now, that's all they say, but is there information that we can gather from that statement? Like, what does it mean that M is the middle of GR? What does that tell us about parts of these triangles? Somebody unmute yourself and tell me. The fact that that's a midpoint tells us what about parts of those triangles?
They have the same side, like on one side.
Yeah, they have congruent sides. Which sides are congruent? Well, we have these two triangles, and it looks like this side, GM, of the left triangle is congruent to MR on the right triangle, okay? But that's not actually in the justified stuff right now. So we're going to click on this justified claim and use it to prove something here. Which one of those? 1, 2, 3, or 4? Hold it on your fingers. Which one of those looks helpful to us right now? 1, 2, 3, or 4? Do you see it? Because it told us that it was a midpoint, and this is now saying, oh, the midpoint divides the line into two congruent parts. So it's going to let us add to our justified claims over here on the right-hand side that these two pieces are congruent to each other. So I click on it. M is the midpoint of GR. It automatically populated that for us because it was in a justified claim. So now I know that this, just GM, is congruent to this, which I really just wanted, what? MR? Yeah, is that what we wanted? So I submit. No exclamation points, no warning signs, no nothing. It just took it. It put it over here in the justified claims. Okay, so let's just evaluate really quick what we have so far. And it put it on our picture too, which was so very kind. We know that this angle is congruent to this angle. So we have at least one angle. We know that this side is congruent to this side. So we have at least one side. But every triangle congruence shortcut that we learned had 3 pieces to it. So what are the 3 pieces? What's the third piece that we don't have yet? Anybody? Can we prove somehow that this side is congruent to this side? Can I give you a warning? It looks like that is true. If you do the other version of the test, the wrong answer at all times is the option that says, well, it looks like it is. Yeah, me and Mr. Elmer put that in just for fun, just to see how many times you guys would select it. Since you've decided to spend your morning with you, I will give you that hint. Don't choose that one. It doesn't work. Okay, so something more mathematical than HM looks like it might be the same as MP. What about the other side? I don't know really anything about GH or RP. What about other angles? Are there any other angles in the picture that might be congruent? We learned about a special pair of angles that happens when two lines cross like this. What are they called? Why do you guys make me wait so long? Vertical, yes. Vertical angles. Do we have any vertical angles in this picture? Yeah, do you see this little guy right here? And this little guy right here? Because they're across from each other in that X, they're automatically the same size, automatically. Okay, so now I'm gonna add a new claim. And my claim doesn't have anything to do with a point or a line segment or a triangle or a quadrilateral or a circle. It has something to do with an angle. And I want to say that two angles are congruent. Okay. And which angles do we think are congruent? This guy, HMG, and this guy, PMR. Okay, so I could have typed in those letters, or I can just click on the picture like you saw me do. I highlighted the angle that I wanted. Okay, and then it puts it in. And that's going to be my claim. It's not proven yet. It's going to require some justification. So to confirm it, I have to back it up with something. And I need to back it up with one of these. Do you see the picture that we want? It's got to, just again, think about numbering them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Hold up on your fingers. Which picture justifies the claim that we just made? Do you see it? Do you see how this picture right here, that X with the two angles, is just like this one? Okay, so it says, now it's going to say HMG and PMR are vertical angles, so they must be congruent, and we submit it. And now it's chilling over here in the justified claims. The justified claims on the right-hand side are all the things that I can use to now create a proof. Now, look at the picture. Again, it has marked everything that we know so far. So we have an angle congruent to an angle. We have a side congruent to a side. And we have another angle congruent to another angle. Do we now know that those triangles are congruent? Yes or no? Yes or no? Yes, because we can use a shortcut. So we're going to click on the triangles are congruent that we're trying to prove. Okay. Now, which one of those, 1, 2, 3, 4, or 5, which one of those represents what we have, the information we have? Show me on your fingers. Good, Abby. Why 3? What does 3 have? What does picture number 3 have? Look at it. It's got It's hard to point to it. An angle congruent to another angle. Then a side congruent to another side. Then an angle congruent to another angle. So angle, side, angle. Yeah? So why is it not this first one? Because we don't have two sides that are congruent. Why is it not this one? Because we don't have three sets of sides that are congruent. Why is it not this one? This one's tricky. We have two angles and we have a side, but it's not that one because in this one, the side is not in between the two angles. When it's angle, angle, side, we're saying that it went an angle and then you keep going and you get to another angle and then the side comes after. With angle, side, angle, the side is between the two angles. So that's the one we wanted. Okay, now watch how easy this is. I want to show that the first angle is congruent. So I just go over to my justified claims and I click on it. And that'll justify an angle. And then I click on these to show that a set of sides are congruent. And then I click on this to show that another set of angles are congruent. And that will show that GHM is congruent to RPM. What should I do? Click submit. What's going to happen? What's going to happen? Oh, my battery's dying. Hold on. That was very anticlimactic because right when we were successful, my battery wanted to die. Okay. Okay, how do you feel about that? Good? Do you want to try another one? Are you bored? Are you tired? Thumbs up if you want me to do yet another. All right, we'll do one then. Here we go. Let me look at the chat real quick. Yes, at least it made a noise to celebrate. Let's do a quadrilateral. I like that plan. Okay. Quadrilaterals. Oh, because I don't have anything. There we go. Okay, now I know which ones I've given you. Let's do one that has, I'm going to make it hard because I'm going to do both quadrilateral, but I'm going to make it something that has algebra in it again so we can play with that dumb algebra manipulator again. So I don't want to go too crazy and make you think this is going to be an impossible situation. Well, I can't find one that's kind of easy and has algebra in it, so maybe we won't do that. Let's see. Maybe that one. Some of these are just ridiculous, honestly. Okay, let's do, we're just gonna try this one, see what happens. Again, I did not give myself a dress rehearsal. I haven't run through these yet, so here we go. We're just gonna try. Okay, so we are trying to prove that angle QRA is 73 degrees. Okay, and the information that we know is over here. We know that that shape is a parallelogram. Okay, so hopefully you, from the notes and the what shape is it assignment, hopefully you are aware that parallelogram, as soon as I tell you that something is a parallelogram, there are quite a few things that are automatically true about that shape. For instance, opposite sides are definitely going to be parallel. Hopefully that was obvious. Opposite angles are going to be congruent. Okay, and opposite side lengths will be the same. Of all of those things, I think the thing that's going to help us the most right now is that opposite angles are going to be congruent. Do you see how knowing, so if that's on there, you can't see it as soon as I'm not hovering over it, but if that angle is 73 degrees, okay, if that's what I'm trying to prove, do you think that it might be helpful to know the measure of this angle that's inside of the parallelogram right next to it? Do you see how that might be helpful? Okay, so that's what I'm going to start with. That's where my hunch lies. So I'm going to try that. I'm going to click on this information over here, that it's a parallelogram. And it's going to tell you basically all the things that are true about parallelograms, and you're going to pick the one that's going to help us. So is it going to help us to prove that the opposite sides are parallel? No, because we're really, in this problem, we're just worried about angle measures. Hunter, get Missy, please. Okay, opposite sides are the same length. Also not helpful. Okay, opposite angles are congruent. Does that help us? Yes, it does. So I'm going to click on it. And it automatically fills in that PQRS is a parallelogram. Okay, and which angle do we want to be congruent? Somebody unmute yourself. What two angles do we want to show? Do I want to show that P is congruent to R, or do I want to show that Q is congruent to S? Which one will help us the most in this proof? Anybody? Are you still there? Hello? Okay. What did you decide? Did anybody decide to unmute yourself and be brave?
Would it be that P is congruent to R?
Yes, thank you, Sophia. We want to do this one is congruent to this one, okay? Because that's going to give us information about the angle right next to the angle we want to know. Submit. Okay, now if it's congruent, what does that tell us? So I'm going to click on the fact that they're congruent. Is there something in here that's going to help me to kind of keep going, keep progressing with this proof? So 3 is going to say segment divides an angle into two congruent parts as a bisector. I don't think we're going to use that one. But actually, I'm looking for something super simple. If I tell you that two angles are congruent, unfortunately, we are forced to go through, like we're forced to go congruent to the measures are equal, then we can use the measure. Or we know the measure, then we have to jump to congruent. So all we have right now is that they're congruent, but do you see how what I'm trying to prove has the little M? I'm trying to prove something about an angle measurement. So in addition to saying they're congruent, I want to say that their measures are equal, which seems like such a silly thing because it's so obvious to us that if they're congruent, their measures are equal, but I need that so that I can manipulate it with this stuff. Okay, and here comes the algebra manipulator. You ready? If I click on this calculator out here, that shows us that the measure of this angle is equal to the measure of this angle. But over here in justified claims, that QPS shows up over here as well, right? Can you guys see that? Watch this magic trick. QPS, drag, click on it, drag, hover QPS over QPS, and what does it do? magic. It turns what used to be a QPS into 107 degrees. So now I am officially saying that this angle right here is also 107 degrees. Do you understand why that gets us closer to our proof being done? Okay, so now look at this picture. Do you feel really confident that this angle out here is 73 degrees? Somebody unmute yourself and tell me why. Why do we know for sure that that angle is 73 degrees?
Because then that line will add up to 180 degrees.
Because they make a line together. Okay, so I want to add a new claim, something to do with angles, and I want something to do with the fact that there is a line and the two angles have to add up to 180 degrees. Do you see it? How about this? Which two angles do we guarantee add up to 180 degrees? This one and this one. You with me? Now, again, that's our claim. We're going to have to justify it somehow. How do we confirm that? Which picture? 1, 2, 3, 4, or 5? Hold up your fingers. 1, 2, 3, 4, or 5? It's a line. There's two angles. They make 180 degrees. Yeah? So I'm going to submit that. Notice, again, no orange exclamation points. So I click submit. Okay? We're so close. I know this is so exhausting, but we're so close. So now all we need to do is use this fact, the 180 degrees, and this fact, the 107, and use our algebra manipulator to make it so that that will subtract and give us 73. Okay, so I am going to, because I have SRQ and QRA is 180, but don't I already know how big SRQ is? Give me a nod, yes or no. Do I know how big SRQ is? How big is it? 107. So watch. I'm just going to turn SRQ into, oh, you have to get it in exactly the right spot. Do you see it? It makes that gray equation, and then I drop it. Like I let go of the mouse. That's all I do right there. So I'm holding it and hovering till it makes the gray equation underneath. And then when I let go of my mouse, it gives me this equation down here. Okay? But that's not quite what I want. I really want it to say what's up here. I really want it to say that QRA is equal to 73. So if it was your job, if you were doing this on a piece of paper, how would you make it say that QRA is equal to 73? What would be your last step? Somebody say it. Hurry. You can even mouth it. I can read your lips. Go.
Do 180 minus 107.
Good job. Okay, I'm going to subtract 107 from both sides. So back again in my algebra manipulator, I'm going to grab 107 by just clicking on it and pull it. And I'm going to pull it to the other side, and the computer kind of reads my mind. I know I want the 107 moved. When I pull it over there, it reads my mind. But it didn't even carry out the subtraction, okay? Total jerk face right here. It didn't even do what I asked it to do. So I have to hover again. Do you see that? Look, it has that, 180 minus 107. I hover over it, and what will it automatically do for me? It will simplify it for me, but until I click on it, it doesn't drop it down there. Okay? And now, once it says this, and that's what I was trying to prove, I push submit. What's going to happen? Does anybody have any idea what could happen right now? No? No? No clue? Oh, there it is. It's like a mic drop, kind of, you know. Feels pretty good. Okay, more? What do you want to do now? Let me check the chat. You guys are so strange. You're absolutely weird, and I love you, and I miss you so much. Okay. All right, tell me what you want to do. More proofs, or we're done? Oh, look what my dog just did while we were doing math. Do you see this cute Easter decoration? He's missing an arm or a wing, whatever. I love her. She's a piece of crap, but I love her. It's fine. Okay. All right. Unmute yourselves and tell me what you want to do, or type it in the chat. Good job. Abby says she's good. She's leaving. Okay, bye. What about the rest of you? More proofs? Sophia's out. Bye. Mason's gone. All right, Jess, what are you gonna do?
I think I'll try some and hopefully good.
Hey, there's some of you that aren't on video. Diana, Rachel, do you guys want to unmute yourselves? Do you need any other help?
I think I'm good for now.
Hopefully I'll be good. We'll see.
Okay. All right. Well, I will end this, and you guys can try some on your own if you want to. And then, again, you can, go both ways. You can do the CanFigureIt, or you can do the test on Canvas. You can try either one. And then just shoot me an email if you have questions. We can open another Zoom.
Okay.
Sound good? Bye.
Bye.